Hi guys, today we shall be looking at the circle theorems from the EDX GCSE curriculum. So first of all, let me talk about the part of a circle. So this is a circle. So from the center of the circle, first of all, the part of the circle is called the circumference. So this part here is called the circumference. From the center of the circle to the circumference is called the radius. The line that divides the circle into two equal halves is called the diameter. Now, when we have two radius, this is a radius, this is another radius. This line here, from here up to here, let's say from point A to B, is called an arc. A line that touches 2 points on the circumference without passing through the center is called a chord. And the part of the circle bounded by two radius and an arc is called a sector. While the one bounded by an arc and a chord is called a segment. And the line that passes through, that touches the circle at only 1 point, is called the tangent to the circle. I hope that is clear. So next, let's talk about the rules. First one, imagine we have a circle and we have the center of the circle, which means we are going to have a diameter. So the angle subtended in a semicircle is always a right angle. So always remember that. The angle subtended in a semicircle is always at the right angle to the center of the circle. Rule number 2. Imagine we have a circle the angle at the center of the circle is always twice the angle on the circumference. So if this is x, then this is going to be 2x. Rule number 3. We have a circle again. Imagine we have a chord. So as we have a chord, the radius of a circle will always dissect a chord at 90 degrees. So it is going to form a right angle. Number 4. The angle subtended from the same segment. Let's say this is segment A and this is another segment B. The angles subtended from the same segment are always equal. So this is a segment, call this x. This is another segment. They are going to be equal. Imagine we have a circle and we have a cyclic quadrilateral inside the circle. A cyclic quadrilateral is a quadrilateral inside a circle. So let's call this x and I'll call this y. Let's call this angle A and I'll call this angle B. So by circle theorem, x plus y is a supplementary angle, meaning they add up to 180 degrees. Same as a plus b also we add up to 180 degrees. Rule number 6. Imagine we have a circle and we have a triangle inside the circle, and we have a tangent as well. Opposite angle to the tangent are equal, so if this is angle A, then this is also A, and if this is angle B, then this is also what? Angle B. Rule number 7, we have the center of the circle again, and we have a tangent. The tangent is always at right angle to the center of the circle. Rule number 8, imagine we have a circle and we have two chords that intersect each other. So let's call this A, and let's call this B, let's call this X, and let's call this Y. So the rule says that X times Y is going to be equals to A times B. Rule number 9. Imagine we have a circle and we have the center of the circle, and we have another point outside the circle, such that we have a tangent to the circle that touches the point, and we have another tangent from the circle that touches the point. Already we know that this is going to form a right angle here, and this also will form a right angle. If I dissect this line here, then what you are going to have is called two congruent triangles. So this triangle here is going to be the same as this triangle here. I hope that is clear. So now let's look at some examples. So triangle ABCD. Angle ABCD are points on the circumference of a circle. Angle ABD is 54 degrees, as we can see, and BAC is 28 degrees. So find the side of angle ACD. So ACD is the same in the same segment as ABD. So that means that is 54 degrees. And what is the reason for our answer? Angle in the same segment are equal. Okay, question 2. We have AOC, which is 168 degrees. So we are asked to find ADC. So for us to find ADC, first we can find this angle here. ABC is going to be half of AOC, which is equals to 168 divided by 2, which is 84 degrees. So if this is 84 degrees, so what is ADC? So ADC plus ABC is going to be 180 degrees. Remember, this is a cyclic quadrilateral, and they add up to 180. And since we know that ABC is 84 degrees, so that will make ADC to be equals to 180 degrees minus 84 degrees, which is equals to 96 degrees. So this is 96 degrees. So what is the reason for our workings? The first one, angle at the center of the circle is twice the angle at the circumference. So that will be the reason for the first one. And the reason for the second one is opposite angle in a cyclic quadrilateral are supplementary. So you have to write that down. A, B, and D are points on the circumference of a circle. Circle O. BOD is the diameter of the circle. BC and AC are tangent to the circle. Angle OCB is 34 degrees. So work out the size of angle DOA. So we are asked to find this angle DOA. Let's label this X. So we know that this is the diameter. So remember, this is a tangent. These two are tangents. So that means this is a right angle. So that means this is a right angle. This also is a what? A right angle. So since that is a right angle, then it means that this angle here is going to be 90. That means BOC is going to be 90 minus 34 degrees. You know what I mean? Actually, 180 minus 90 minus 34 degrees. So I just truncate this to 90. So 90 minus 34, that is going to give us 56 degrees. So that means this is 56. This is also what? 56 degrees. How do I know that? Because I know that triangle AOC is similar or congruent to triangle BOC, as we can see from the previous row. So that means if this is 34, then this is also what? 34 degrees. Hence, how do we find X? That means X is going to be 180 minus 56 minus 56 degrees, which is equals to 180 minus 112 degrees, and that's going to give us 68 degrees. So X is 68 degrees. BC are tangent to the center of the circle, and A, B, and AC, B and C are points on a circle with center O. So we can see that. So these are points, and A, B, and AC are tangent. So these two are tangent, and BOC, which is this angle here, is 130 degrees. So work out the size of BAO. So we have to find BAO. So which means we have to divide this into 2. And we have to find this angle. So just like the previous question. So first of all, we have to divide BOC by 2. So BOA is equals to half of BOC. And that's equals to 130 divided by 2, which is equals to 65 degrees. So if this is 65 degrees, and we already know that this is a right angle, so what is BAO? So BAO is going to be 90 minus 65, which is equals to 25 degrees. So BAO is 25 degrees. A and B are points on the circumference of a circle with center O. PA and PB are tangent to the circle, and angle APB is 86 degrees. So work out the value of X. So I forgot to mention one of the rules in the second theorem. Let me just quickly include that. And the rule is, let me make that rule number 10. When we have a circle bounded by 2 radii forms an isosceles. So this is the same as this, and this angle is the same as this angle, and this angle is the same as this angle. So make that rule number 10. Now back to our question. Already we know that this is 86 degrees, and we know that angle APB plus AOB is going to add up to 180 degrees, as we already know. So that will make AOB to be equals to 180 minus 86, which is equals to 94 degrees. Yeah, so if this is 94 degrees, so what is x? We know that this is an isosceles, so if this is x, this also is x. So that will make 2x plus 94 equals to 180, which is sum of angle in a triangle. So 2x is going to be equals to 180 minus 94, which is equals to the 86 we got before. So that will make x to be half of 86, which is equals to 43 degrees. So x is 43 degrees. So this is a triangle. Inside, R and S are 2 points on a circle with center O. Okay. TS is a tangent. So if TS is a tangent, that will make all of these to be a right angle. And that will make the internal angle here to be 90 minus x. So prove that angle ROS is equals to 2x. So how are we supposed to prove that? First of all, we know that triangle ROS, the sum of triangle ROS is 180 degrees, correct? So like I said, I know that OST is equals to 90 degrees. And what is the reason for that? Tangent to the center of the circle let me just change that to make it easier. The tangent is 90 degrees to the center of the circle. So we already have that. So that implies that RST plus OSR is going to be equals to 90 degrees. And we know that RST is x, and OSR, we don't know what that is equals to 90 degrees. So that will make OSR to be equals to 90 minus x. So we know that if this is 90 minus x, then it implies that ORS is equals to OSR. So what's the reason for that? Base angle of an isosceles are equal. Hence, that implies that ORS plus OSR plus ROS equals to 180 degrees. So this is going to be 90 minus x plus 90 minus x plus ROS equals to 180 degrees. So that implies 180 minus 2x plus ROS equals to 180 degrees. So this we cancel out, and minus 2x plus ROS equals to 0, and that will make ROS equals to 2x as expected. Question 7. In the diagram, O is the center of the circle. A and C are points on the circumference of the circle. BCO is a straight line and BA is a tangent to the circle. Given that AB is 8 centimeter and OA is 6 centimeters, explain why angle OAB is a right angle. Very good. Already we know that since BA is a tangent, therefore an OA is a radius. OA is perpendicular to AB. Therefore, OAB is right angle. Hence, work out the length of BC. So how are we going to find BC? All we have to find is to find OB first. So OB is equals to the square root of 6 squared plus 8 squared by Pythagoras theorem. That will be equals to square root of 36 plus 64, which is equals to the square root of 100, which is equals to 10. So if OB is equals to 10 and OC is equals to 6, because this is a radius, just like this, just like OA. So that implies that BC is going to be OB minus OC, which is equals to 10 minus 6, which is equals to 4. So that implies BC is equals to 4. A, B, C, and D are points on a circle with center O. BC is equals to CD, and BCD is equals to 130 degrees. Write down the side of BAD. So first of all, if this is 130 degrees, that implies that BAD is going to be 180 minus 130 degrees, because we know that this is a cyclic quadrilateral. Yeah? So BAD is going to be equals to 180 minus 130 degrees, which is equals to 50 degrees. And the reason for our answer is BAD plus BCD is equals to 180 degrees. Work out the side of angle ODC. ODC, which is this angle right here. Okay. So since this is an isosceles, this is the same as this, so it makes sense to say that this opposite angle are equal. That is, this is the same as this as well, because it's going to be a radius, obviously, since this is the center of the circle. Yeah? So this is a radius, this is another radius. So what we have is more like a kite, right? Now, since we know that this is 130 degrees, and we know that this is 50 degrees. So if this is 50 degrees, this is going to be twice of that. BOD acute is going to be double of that, which is 100 degrees. So this is 100. And BOD reflex, which is the other side, is going to be 360 minus 100. So reflex BOD is going to be 360 minus 100. We don't even need that, do we? Which is 260 degrees. We don't actually need that. So since I know that this is 100 and this is 130, then it implies that 100 plus 130 plus, let me label this x, this will be the same as x. X plus x is equals to 360 degrees, sum of angle in a quadrilateral. So that implies that 230 degrees plus 2x equals to 360 degrees. So 2x is going to be equals to 360 degrees minus 230 degrees, which is equals to 130 degrees. So that will make x equals to 130 divided by 2, which is equals to 65 degrees. So that makes ODC is 65 degrees. And what are the reasons for our answer? Already we know the reasons. So question 9. Pause this video and try to attempt it before you see the solution. Alright, so work out the value of x. So since we see that BAD is equals to 70 degrees, already we know that BOD is equals to 2 of BAD. So that will make x to be 2 times 70, which is equals to 140 degrees. So x is 140 degrees. So what is the reason for our answer? The angle at the center is twice the angle on the circumference. Hence, find the value of y. So for us to find y, since we know that this is 140 degrees, so the reflex of that is going to be 360 minus 140, which is 220 degrees. And that implies that y is going to be half of that. So that means y is 110 degrees. So give a reason for our answer. There are two reasons we can give, and both are correct. The first reason is the angle at the center, or the angle at the circumference, at the circumference is half the angle at the center. Or we can say that y and 70 is 180 degrees because they are supplementary, because that is a cyclic quadrilateral. Or what is y again? BCD and BAD. BCD and BAD are supplementary angles. Both are correct. You can pause this video and attempt this question before you see the solution. Okay, let's work it out. The diagram shows a circle with center O. ABC are points on the circumference. DCO is a straight line, as we can see. And DA is the tangent to the circle. Angle ADO is 36 degrees. So work out the size of angle AOD. So AOD is the angle we have right here. And there's no doubt, already we know that this is a right angle because this is a tangent. So if this is a right angle, that will make AOD to be equals to 180 minus 90 minus 36, since we know that this is a right angle. Yeah. So that will imply 90 minus 36, which is equals to 54 degrees. So AOD is 54 degrees. Work out the size of ABC. So what is the size of ABC? So if this is 54 degrees, this is also what? 54 degrees. Make sense? And what is the reason for that? No, ABC is not 54 degrees. That is absolutely wrong. ABC is going to be twice of AOC. Sorry, it's going to be half of AOC, which is going to be 27 degrees. ABC is 27 degrees. And the reason for our answer is the angle on this circumference is half the angle at the center of the circle. Hope that makes sense. You can see from here that instead of B to be at this point, if it is right here, it's going to look exactly like one of the rules that we talked about before. So this is going to be 27 degrees. It's the same. Okay. B, D, and E are points on a center, on a circle center O. ABC is the tangent to the circle, BE is the diameter of the circle, and angle BDE is equals to 35 degrees. Find the size of angle ABD. So this is angle ABD, so let's call it X. Since we have been told that this is a tangent to the circle, so what does that imply? It implies that all of this is a right angle. So there is a right angle. So it only makes sense that we assume that ABD plus DBE is equals to 90 degrees. So that is X plus 35 equals to 90 degrees. And that implies that X is going to be 90 minus 35 degrees, which is equals to 55 degrees. So X is 55 degrees. And what is the reason for our answer? The tangent to the circle is at right angle. So the reason is the tangent is 90 degrees, or is a right angle to the center of the circle, or to the radius of the circle. Both are correct. Find the size of angle DEB. So DEB, which is this angle here, let me call that Y. Already we know that this is a diameter, yeah? So that implies that this angle right here is a right angle. That was our first rule. So what does that tell us? That implies that B plus D plus E is 180 degrees. D plus B plus E is 180 degrees. And since we know that D is a right angle, so that will make 90 plus 35 plus E equals to 180 degrees. So that will make E to be 90 minus 35, which is also 55 degrees. So hence this is 55 degrees. The second way of solving this is to remember the rule I said for a triangle. When we have a triangle like this and we have the tangent, this angle right here, if it is A, then this is A, and if this is B, then this is also B. So we can see from here that this angle here is actually the same as this angle here. Can we see that? So that also makes sense. So we can see that since X is 55, then angle DEB is also 55 degrees. So both ways are correct. So any of those reasons are also valid. So I can say that the angle So I can say that the reason for this is DEB plus DBE are complementary angles, meaning they add up to 90 degrees. Or I can say that DBA equals to DEB. So the reason is DBA is equals to DEB. DBA is equals to DEB. Yeah, and the reason for this is opposite angle cyclic triangle are equal. Not opposite angle. In this case, it is not opposite angle. It is corresponding angle. Corresponding angle in a cyclic triangle are equal. P, Q, and T are points on the circumference of a circle with center O. The line ATB is a tangent at T to the circle. PQ is equals to TQ, and angle ATP is equals to 58 degrees. Calculate the size of angle OTQ. OTQ is this angle A, X. So that is quite easy. So one thing I would like to bring out is this. Since we know that this is an isosceles triangle, so it makes sense that we can divide this triangle into 3. Yeah, so if this is X, this is going to be the same thing as X. Yeah, since we know that that is the radius of the circle. So let's figure that out. First of all, we know that OT is a tangent, is perpendicular to ATB. So that implies that ATO, let me start with that. ATO is equals to 90 degrees, is a right angle. So this is a right angle. And what is the reason for that? You already know that the tangent is always at right angle to the center of the circle. So if that is 90 degrees, that implies that PTO is going to be equals to 90 minus 58 degrees, and that will be equals to 32 degrees. So this angle right here is 32 degrees. So if that is 32, then this also would be 32 degrees. Yeah, and if both of them are 32, so that implies that POT is going to be equals to, which is this angle A, is going to be equals to 180 minus 64, which is sum of angle in a triangle, and that will be equals to 116 degrees. Makes sense? So if that's 116 degrees, that implies that PQT is going to be equals to half of POT. That is, angle at the circumference is half the angle at the center, which is equals to half of 116, which is equals to 58 degrees. So if this is 58 degrees, that implies that OTQO is going to be half of that. So TQO is going to be half of PQT, and that equals to half of 58, which is equals to 29 degrees. So if this is 29 degrees, so that implies this is also what? 29 degrees. And what is the reason for that? The base angle is always equal in a triangle, in an isosceles triangle. So therefore, OTQ is 29 degrees. D, E, and F are points on the circumference of a circle with center O. Angle DOF is equals to 130 degrees. So work out the side of angle DEF. That's very obvious. So that is half of it, which is 65 degrees. And what is the reason for that? Again, what we know. Angle at the circumference is half angle at the center of the circle. In the diagram, ABC are points on the circumference of circle center O, and ABC is 85 degrees. Work out the size of the angle marked X degrees. That's also obvious. That is double of 85, which is 170 degrees. And the reason for our answer is the same. Angle at the center of the circle is double angle at the circumference. The last question, but not the least. So we're asked to find X. This is very easy. Since P and T are points on the circumference on the circle, and PT is a tangent. If this is a tangent, that means this is a right angle. And if that is a right angle, so what does that tell us? That means this angle here is going to be 90 minus 32, which is 58 degrees. If this is 58 degrees, we know that this is a straight line. So this is going to be 180 minus 58, which is 142 degrees. If that is 142 degrees, that means this angle here is X, and this is also X, because it's going to form an isosceles triangle, and that implies that X is going to be half of 58, which is 26. I hope that makes sense. Is it 26 or 29? X is 29 degrees. So X is 29 degrees. If you have any question, feel free to contact me at my inbox, which is oyederomuhammad@gmail.com. I'll see you in my next video. Remember to like and subscribe to my YouTube channel. Thank you.